Okay, so welcome to talk a little bit about climate impact of software testing. I chose this cover picture here especially because I love snow, and snow is beautiful. These are snowshoes. If you don't know what they are, picture is about snowshoes, traditional snowshoes made of wood, leather, joints, things like that. These days they actually made with plastic and metal and all kinds of things. But you know, it could be that we don't have any snowshoes in a few decades. We might not have any snow, and that's a big fear for anybody who lives with snow, like people in Finland, where I come from. So we do need to think about the climate and try to save the climate, and testing has a part of that. So testing also has an impact on climate, and we can help keep the snow, basically. So I'm a man with many hats. Recently I've won lots of awards also. We won in bold there. Eurostar award on testing, exemplary DevOps instructor, tester of the year. So lots of nice things. I think they are maybe due to my long career in testing, but also because of the books, like we heard about Dragons Out. Also I have a new book about test leadership. It's just published on Monday in Finnish, but next year it will be available in English. So lots of things. So I'm a man of many hats, so just one slide per hat. Most of the time I'm working at Knowit, that's 4,500 people in Nordic countries, and I'm training and coaching, assessing, testing and processes there. My other hat is my favorite hobby, if you like, my side business, so that's writing books. Especially with Dragons Out books in many languages, and there my modest goal is that every teacher in the world would have access to software testing classes and could explain their children that what testing is. Maybe get some of those people, kids, interested in software testing. My third hat is ICQB. I'm very much active in this largest organization in software testing in the world. I was in the exec for 6 years. And then my next hat is Team MI. This is my latest hat, I would say. So I'm actually in a board of directors on this organization. Much smaller than ICQB, but very much in cooperation. And you know, it's about improving testing. So these are my 4 hats. It seems that my climate hat is also coming up. Maybe I need to add in a slide my 5th hat. But I think it's also part of my Knowit career, because the company Knowit is actually very much a sustainable company and wants to be a forerunner of sustainable software business in the world, and you know, carrying the UN sustainable agenda ideas throughout its IT business. So very nice thing. So I think it's also coming from there. This is the agenda. So we talk about what's green ICT, what is green testing. We talk about carbon footprint. Talk about test environments a little bit more, and then other types of ways to minimize carbon footprint. And a little bit of what can be next actions for all of you to try help reduce the climate impact of software testing. So let's first talk about green ICT. What is green ICT? Well, of course, it comes from a point that climate is changing. It's changing for the worse. It's warming. In Paris Climate Conference 2015, so that's 8 years ago, a limit of 1.5 degree warming compared to pre-industrial levels was agreed, and you know, there's a big hurry to get the measures done, get the actions done so that this can be met. It might not be possible, but I think we need to be positive and try to make it happen. United Nations is driving sustainable goals. One of those 17 goals is the number 13. That's called climate action. So that would be here in the corner, there. But also other things, of course, are interrelated. So we could think about different kinds of actions that can help the world to be sustainable. But I think the climate is there, the key thing that makes things work, climate action. So green ICT is taking ICT into this sustainability. So there are ways to make ICT, create information system, create software that can be considered green, that can be considered helping the climate, that can be minimizing the impact of ICT on its own. Janne Kallio, a Finnish author of a book, Green Code, has said nicely that all viable avenues must be explored and ICT industry must play a role. So even though ICT is actually often the solution to bad environmental habits, it's also a source of CO2 in the atmosphere, and we can and we should carry our part of that. So here are two terms that I'm going to use, carbon footprint and carbon handprint. So I think most of you have heard about the word carbon footprint, and that means that if whatever we do, we are emitting carbon dioxide into the atmosphere, and that's carbon footprint. So we can't avoid that really. We can try to minimize that, and it's there. The less carbon, the better. But carbon handprint is actually all those actions that we can do to help minimize the number of carbon there. So from trying to minimize something negative, we can actually move to being positive, whatever positive actions we can do that can help the climate. So that's carbon handprint. So let's move from footprint to handprint. In ICT has a great chance, and testing within ICT has a great chance actually to go for the handprint. So that's my main message. So it's a fact, carbon footprint exists. We can measure how much footprint we do with our actions when we fly here. For example, the airplanes have a quite significant number of carbon footprint. We can try to minimize that. Sure, I could take a train, I could take a bus here, for example. But then again, if I talk here, maybe this talk has more impact than taking the airplane, and the balance is better. So we can try to move towards carbon handprint. So I believe my talk here will be an act of carbon handprint and not footprint, even though there is that as well. So this is the kind of thinking we need to engage. Let's try to find positive ways of affecting the climate. IT has carbon handprint, that's for sure. And I believe this 10 years ago, I was extremely happy to work in ICT industry because I hadn't really thought it through. I thought that, we are, in ICT, we are just helping environment. We are the good guys. We are just, helping the customers, helping the companies to get rid of paper in their activities, to streamline processes with great software, meaning less energy will be used, no pollution to environment, things like that. So actually ICT has this nature of creating this handprint. That's very true. But in recent years, we come to realize that we also have the footprint. And we need to minimize that. So we need to understand what that footprint is and with what kind of actions can we then minimize this footprint. So let's talk about green testing. Testing is part of ICT, information and communications technology. So testing can help. On its own, it can't. It's part of ICT, but as a part of ICT, it can work. There are two ways how it can help. One is it can help measure what kind of footprint or climate impact ICT is having on the climate. In the same way as it can measure if something works, or if something is fast, or if something is usable or accessible. We can measure if something is good for climate or not. And we can also choose to be as green as we can in our own activities. So it could be using test environments. Can we use less test environments? Maybe that's better. So there are green aspects there. And there are companies who are looking into this. Here I use an example from Experimentus, who have put together practices which are, you could say, normal, regular testing practices, if you read the lines there. But they are actually about sustainability. So lots of good testing practices go hand in hand with being good, they make sense, and also being good for climate. So optimize resource utilization. The less resources you use, the better for climate. Use test automation, you're going to be faster, better for climate. Use performance testing and optimization, again, same thing. Use early work, so any preventative work, defect prevention, early detection, it's always better. Environments should be used efficiently. Test techniques should be chosen that minimize the number of tests, again, less carbon footprint, and share how things are done. So they all make sense from point of view of good testing, but they also have an impact on sustainable software testing. I'm going to talk about more of these a bit later, based on a workshop that we ran some time ago. So I'm coming back to this topic. How can we measure the footprint? Well, we can tie it to quality criteria. So there are different sources for quality criteria. One source is definitely the ISO 2510 standard, which has different aspects of software quality. And as testers, we can look into quality criteria, we can take that quality criteria, and then we can figure out a similar testing practice. How can we measure if that quality criteria is met? So that's natural. I think we should add something there, climate impact. So that would go under performance efficiency, really. So can we do something, but can we do that something with as little energy as we can? And that would be, taking it through, that would be less carbon dioxide emitted to the atmosphere. So the quality standards don't really always mention the climate impact or sustainability that clearly. They should be adapted to include it. Of course, you could read between the lines, and when it says performance efficiency, that's already saying, okay, less energy, right? So if you are looking forward to the performance efficiency quality attribute, you are probably doing quite nicely with your climate impact work. There are other sources that are doing similar things. I chose here two. One is quality criteria listing by Rickard Edgren at the Test I. It's a great listing, a lot of quality criteria, a lot longer listing than ISO's listing. It actually does have sustainability, so the circled word there or sentence, it's sustainability. So sustainability is actually in that list of quality criteria as we speak. Also, if you look at the company society, they have taken an extension, company-wide extension to ISO 2510 and added sustainability there. So I think we can equal sustainability and climate impact pretty nicely. I'm talking about climate impact here, but I think we can agree sustainability is kind of the same thing. Another aspect is the cost. And this one I think is good for the leadership of companies. So if it starts saying that, okay, we need to do all this and this testing, but also we need to do the climate impact estimates, that can feel like more cost, but it's really not. Because if you look at some quality cost models, and this Feigenbaum's model is quite nice in that, so let me just explain it quickly. So there we have on the left and the top prevention costs, and we have appraisal costs on the top right. So these two are costs that can be done consciously, trying to minimize the impact of problems, of defects in the software. So they're preventive actions, really. On the bottom, you've got failure costs. So if things go wrong, if there actually is a defect, you need to fix it, you need to retest it. And if that problem occurs at the customer, with bottom right, failure costs might happen. So you might need to pay penalties. Customers might lose money, maybe their lives if it's a very safety critical thing. So there's always cost, and you can try to move the cost to the upper part, so the preventative measures, and that can work. Now, if we add climate impact here in this picture, it's actually all over. So when we talk about preventative quality measures, we also can add, let's also think about climate impact, the sustainability, when we are deciding about the software at that point already. And that's the cheapest place to take climate impact into account. In the appraisal cost, so when we test, basically, we can also measure the climate impact. So let's see how cost-effective, how much energy, how much cloud environment minutes our software uses. So let's measure that, and we can try to find if it actually works in a good way. On the failure costs, again, we can see how much time and energy we are using to test, to find those problems so we can fix them. And in failure costs, we might have not only your typical penalties, like a clause in a contract, but you also have a climate-specific sanctions. You can have the CO2 compensation that you must do, and it really depends. So from cost point of view, it makes sense to start taking climate impact into account early on. It's cheaper that way. And then can you apply this climate criterion? So we would be coming from the quality criteria. Well, when do you apply quality criteria? Well, all the way through a process. So when you think about your requirements and then your definition of done of your software, it should include climate impact there. When you do your test planning, test execution, you should think about the climate impact there. When you do reviews, review of a code, review of a test plan, review of test case, test automation scripts, whatever, think about it as well. So, and all the way through. So it's something you should take into account throughout your work. So let's talk a little bit about test environments. So here I was looking for the famous Boeing picture in the internet, and out of the many pictures I found this one. I like this one because I used to skateboard when I was a teenager, so it's a skateboarding bug there. Just a nice picture from rectest.com. So it does say that the later you find a defect, the more expensive it is. So that's, I think we all know this. It's like this regardless of the kind of a life cycle model they use, agile or traditional or DevOps or anything. If you find something earlier, it will be cheaper. If you think about it from a point of view of test environments, if we find defects later, that will mean more time spent on those test servers, more those test environments, test servers, and those test servers will also be larger, and that will mean bigger carbon footprint. So I spell it out. It's worse from climate point of view if you find defects late. So you want to try to have the early testing. It also means that the environments are smaller, and again, the energy usage is less. So it does make sense to have small early environments, and it's good for climate. Let's think about the test environment from point of view of virtualization and cloud. So now these are, of course, great things, and I'm very happy that cloud is here these days. You got your Amazon, your Microsoft clouds, etc., etc. Google Cloud, the biggest three at the moment. And what it enables, of course, and on its own, the cloud environments are trying to be cost-effective, and in that way also energy efficient, and that way climate impact is less. They are trying to have power sources that are renewable energy like wind or solar, etc. So already using cloud is better. It's using a green choice, right? But within that, what you can do is you can create a test environment that is created on demand, virtualized on a platform. Let me just get those boxes there. So if you are using test environments which are not standing somewhere in your corner of your basement, but rather they are in the cloud, you can have more test environments running in the same machine using the same amount of energy. So using a cloud is an environmental action. So using virtualization, using serverless architecture, function as a service, whatever, new terms come up all the time, containers, Dockers, using these technologies that enable virtualization and basically many test environments running in one computer, that's good for everybody. So move to this. Don't use your old servers, even though it's quite typical that the production servers are kind of retired in the testing use, and then you are running them, but that's not really environment friendly. Maybe you want to recycle them and rather use also test environments in cloud. So that's a great idea. Another aspect of test environments is automation. So if you can get your environments up and running quickly, you will use less energy. So if you have your CI/CD pipeline, if you have automation in that pipeline, so continuous delivery pipeline, so if you are running a script and that script is setting up a new environment in a cloud, provisioning it, getting it up and running, deploying your own software there, deploying the test scripts there, running the test scripts, and closing it down in the end. That's very, very efficient. And you are running your environment basically only for the duration of time of your tests. So the actual getting the environment up and running and down is very quick because of the automation in those environment setups. So you should think about CI/CD pipeline automation from this point of view as well. So here I just had added a picture of your typical CI/CD pipeline. So you can early on use environments to get quick feedback. That environment will be quickly up and running through a script. Some tests are run there, you get feedback, you can fix things, you can go for the next step. And I think the key here is that you don't run all the environments in one go. You first run some tests in some small environment. You get feedback if those tests pass. Only if they pass, you use more energy and you go for the next environment to run more tests and so on and so on. So you have a pipeline where you have dependencies. You don't want to run all your tests all the time. You want to have a sequence, a very well optimized sequence where you can even consciously think about the energy efficiency of those environments. So that's a great aspect. And I chose it to be here a separate subtopic because I think test environment usage is probably the biggest thing where we can impact, where green testing has an impact. But there are other things as well, so let's take a look at them. Now these ones come from a workshop I mentioned. So a year ago, I took part from testing point of view as a testing rep in a discussion in a green ICT ecosystem, where there's this great initiative going on in Finland at the moment. And they got some 30 or 40 people together who were very much into the green ICT, and they had a workshop and tried to identify different actions related to testing that can help the testing to be also as green as possible. And basically we had a value stream from product vision to requirements to coding to testing to production, etc. And throughout the value stream we were figuring out, okay, what impacts can we have? So here I have chosen, based on value stream steps, different ideas. So this first slide is about product vision. So already when we think about the product, a software product, how can we take carbon footprint and testing into account? Well, a little bit mixed here, but it's anyway mostly testing. Well, we can add carbon footprint as one of the quality criteria, so we can decide to go for that aspect as well in our creation of ICT software or product. So sustainability needs to be part of that. We need to require that, so quality criteria, sustainability should be there, and energy efficiency specifically should be there. So we need to really spell it out as part of the product vision. So sustainable big picture will lead into smaller carbon footprint. Next one is requirements. So what can we do there? Well, of course, requirements should be discussed through enough. So if we have a good understanding and we all understand the requirements in the same way, epics and user stories, whatever, they will go through the correct way. They will be implemented with as little problems as possible. So we need to spend enough time in the requirements. So it would be collaborative user story creation, basically. When we do requirements, we do need to mention that, okay, the code needs to be energy efficient, and the tools that are used for that needs to be energy efficient. So again, the quality criteria, sustainability will be there. As an example, how to architecture with data, we could even decide that let's have static data over dynamic data. So for example, if we have a app, let's say a portal, that has a weather part in the portal. Now, if you code that, you could just add a link to some website, some weather forecast website, and get the latest weather forecast always here. But what actually it results is that your website will be polling the weather forecast website all the time, every second, depending on how many users you have. And is it really needed to have this dynamic polling of weather forecast every minute? Probably not. Maybe it's better to have a static, let's say, last hour's forecast. So you poll the weather forecast website once in an hour, and then you use it to any users who are accessing your website during that hour. So you can probably go to 1/10,000th of parts of energy usage in that small part. And any architectural decision there can be in the same way. And how can you notice it? Well, you need to put your testing glasses on, and you need to look at the architecture and try to identify these places where you have just unnecessary traffic and unnecessary usage of energy, in other words. So it's all about the code structure as well. Also, you could think about the number of requirements that make up your product. So maybe your minimum viable product actually is enough. Do you need anything more than MVP? Why would you create more? It takes more time and energy to create it, and it will also use more energy when you run it. So why don't you have just your bare bones software if that actually is enough? Of course, not always it is enough. You might want to go to your full product vision, but think about that. And then you want to review all requirements, all the stories, anything, architecture, database design, for the climate impact, and obviously also for testability and test automation. Because, as I said earlier, when you have early testing, easy testing, it means less energy consumption. So you want to try to achieve easier testing in your review requirements phase. Next bit is, let's just get those boxes where optimized test suite. So how about test design and test execution? Is there anything we can do there? I think the key word is optimization. So when you have especially when you have a bigger product, you will end up with more and more tests, and those more and more tests will be at some point duplicating each other. They won't be after a year or two an optimal minimum set of tests that fulfill your requirement about good testing. So you want to take a look at your test suite, see if you have duplicates, remove duplicates, see if you have prioritization there. Are some tests more important than others? Maybe you can just live without some of those tests, remove them. Even if you need all of the tests, is there an order of your tests that has an impact? So maybe you want to prioritize the tests that have most likelihood of finding defects. And especially if you have a CI/CD pipeline, don't run all the tests in one go. Choose the prioritized tests to be run first. Run those first and find the problems there, fix them, and only after that you go for the other tests. So that will be already less energy spent, and that will help. So to achieve this, you can use test techniques, risk analysis, and AI models. So test techniques already reduce the number of tests that you need to get to your goal of good coverage. Risk analysis gives you priority where do I need to really test, apply that and then test against the risk. And AI models are actually doing these both things these days. So AI is helping the test optimization. I've seen already figures in some companies who are providing AI test optimization algorithms that you can do with something like 1/10 of your test set if you let AI optimize. You pour everything into the AI algorithm and it crunches it and says, drive these tests first, and you are going to find most defects. So modern technology is helping us here in this part as well. In the test execution part, I think it's a carry on from the previous one. So you prioritize your tests. Okay, run the easy and fast tests first, get more information from those tests, and only then you run the next tests. You could use also simulation, that means a smaller test environment, or just use a smaller test environment to get some actual knowledge about how your software works, and for example, if the functionalities work, and only then you run it in a bigger environment to see if performance is what you expect. And from an on-demand point of view, don't use static test environments that are always on and using the energy all the time. Rather, get your environment up and running with on-demand script and close it when you don't need it. So small steps, but they all add up to the same positive outcome. Test automation. Test automation on its own helps. It does help because it makes executing tests faster. So you are using those environments, even if they have small environments, you're using those environments less time. So you want to have this automation done. And of course you might think, yeah, executing a test automation script takes a little bit of time, but you are probably going to spend 10 times that when you develop that script. True, but you are going to develop that script in a small environment on somebody's computer, and then you can just utilize it over and over again. So test automation does help on its own, also from sustainability point of view. And you can add test data creation there as well. So that also helps. So you don't want to have data created manually. You want to have it done by scripts, and that's really a good idea. So use scripts and automation all over. So that means basically faster testing, and that means, again, smaller carbon footprint. I think we get the key phrase now, smaller carbon footprint. Yeah. And then we have the phase where our software is in production. And we don't stop there. We keep monitoring, we keep observing how it's using energy, how the customers are using it, which parts of the software customers are using. And based on that, we can optimize how that system is using resources, and again, as an extension, how much energy is spent. Also, if we notice that some parts of the system are not used at all, some functionalities are just not used, why don't we just close them down? So the software will be slightly smaller, it will use less energy when it's running on some server in some cloud. So let's keep monitoring the customers also from this point of view. Obviously, we all want to monitor customers anyway and see that the production is working and the customers are getting a great user experience. But it's not just the customer experience or user experience, it's also how much energy it uses. So production monitoring means, again, smaller carbon footprint. And I think between the lines, I've mentioned Agile and DevOps all the way through. So if we want to do something early and get something done right the first time, Agile and DevOps are great ideas. So I think we should all move towards Agile shift left practices where we can do the early defect finding, the early quality, do things right the first time, that sort of attitude. Agile and DevOps provide that anyway, so they are good from many points of view, but also from point of view of climate. So I think I was an Agile and DevOps believer already, and I think after looking into the climate impact, I'm even more a believer of these methodologies. So that means basically less rework, and that means less time in environment, that means less carbon footprint. Okay, so what can we all do? Now we understand maybe a little bit better that all our actions throughout creating software and testing have an impact, sometimes a small impact, sometimes a great impact. What can we do? Well, we can learn even more. There are actually surprisingly many books already and websites and societies around green ICT, and not that many around green testing, but more and more also coming up, which is nice. You can also look at your own software development. How green is that? Is there something to optimize? Can you add automation? Can you go into Agile and DevOps if you haven't already? Can you just add more test automation? It does help. So the things that are good for testing and software development in general are also good for climate. And this is a good message. We don't need to do something extra. We need to observe the sustainability point of view, and it will be also good for climate. So let's try to make our testing greener. Here are some links. You get the material. It will be in the internet afterwards. And so read some more. I encourage you to pick up some of those websites or books, and it's time for questions.
Okay. Applause, everyone, for Kari. I must admit that I haven't realized that actually what we are doing with the testing process and with the overall improvements in it, it actually affects also the environment. So that was a great insight. I have one note that I wanted to take. Actually, from what I saw recently, Jira from Atlassian went to full cloud, as well as Postman. So I guess they are doing it on their own, so they could update everything in one go. But this actually affects the footprint, right? Because you don't have to chase each one of the users to actually, hey, update my software. You can do it in one go, and actually, yeah.
That's true. Yeah, it's more efficient. It's also good for climate. Yeah.
Also, doing the test automation solutions as a one-stop shop, or maybe reusable, reusable cart of, I lost the word basically. But yeah, reusable automation, just like Matthew does with Marcin, as an example. Okay, I am stealing your time, so any questions? Okay.
Thank you, Kari. I just want to maybe counter something. Last week, somebody said to me that actually cloud is has a bigger environmental impact, and it's time to go back to having the servers in your basement. Mm-hmm. And I have no idea. But like you're saying, I guess in some way we should look at our cloud providers and see how green they are, is the answer. Yeah,
I think cloud providers are very much conscious of their impact, and I think having cloud means you have easier access to environments, and then you will use more cloud. Basically, you will use more software, and that has resulted in more software in the world, more energy used. So from that point of view, cloud is bad. But at the same time, if you compare one cloud computer running on a shared platform and then one actual environment running, that one computer is less energy. So I think we just need to keep pressure on the cloud companies, and they do it on their own anyway. Keep pressure on them to make their environments as energy efficient as they can. And they are doing things like edge computing these days. So they are trying to minimize the number of data moving from one data center to another, or one customer to the data center. They're actually trying to put things physically close in the network of computers to the user, so that it's going to be less energy efficient, and it's going to be faster. So again, it's many things coming with the same decision. It's going to be also cheaper. Yeah, good point.
Hi, Kari. A follow-up question, because it's quite related. One of the things with AI is the cost, right? Yeah. And we don't realize how much it costs behind the scenes and how much energy it takes to have ChatGPT running. So one of your points, one of the bullets was to use AI models. I don't know if you explain how that can improve, or if I miss it.
Yeah.
But can you detail a little more?
Yeah. So one thing we need to realize is that when you teach an AI, you will teach an AI with lots of material, and that's the phase where you use lots of energy. That's using lots of computer time. But when you have a model ready, then you can just use it, and it's just like any other software. It's not taking that much energy. Maybe ChatGPT 4 is doing learning all the time, and that's not good. But if you take one of those test tool solutions that have within them a model that is optimizing the order of your tests and suggests you're going to try this test first, that learning has been done already. That energy is used. And now you have that tool available that has this capacity of optimizing and prioritizing for you much faster than you could do it as a tester. I think it makes sense to use these tools. But yeah, you need to compare the energy spent on creating that and then using that. And yeah, it's not an easy choice. But at the same time, the world goes forward and they get new solutions anyway all the time, and creating the new solutions uses energy. Not an easy answer.
We'll squeeze one additional question.
Thanks, Kari. Very interesting topic to talk, and I think it all comes to one point. It's cost savings, and using the resources. So, as it was pointed out, cloud is much easier to use. If I put one server on 20 servers, I just change the number and hit enter. It doesn't matter. I don't see the cost. The thing is, what management is, I think, often not checking how much we are paying for those cloud services. And I saw those numbers, and those are ridiculously high on a monthly basis. So if anybody would be checking that and getting somebody to do data analysis to find out how much we are spending and why, because I as a person, first I can go and put dummy questions into some AI service, which will generate me the answers. Also, I can use my brain for 3 minutes because the resource is already on and it's kind of free. I can put better inputs, get some outputs, and use those outputs then to do my code better, run it locally, not just push to the pipeline and see what happens. Because many developers do that. And then, of course, spinning up and turning down the test environments, just do it more efficiently, not have 40 minutes spun up time and then wait for another 2 hours in case some job will appear, which most probably will not, and stuff like that. So just using the resources, and at the end, really, nobody will buy like, hey, kids, go green. But like, let's save hundreds of thousands of euros a month on running our cloud services, and that's something we can really easily sell and also analyze and do it.
Absolutely. Yeah, cost is something that the management of companies always understands. And luckily, using less energy is less money, and that's good for climate. So yeah, that's what we need to emphasize. So I think the key word is transparency. Let's make it transparent how much money we are using on those test environments or cloud servers in general, and then we can try to optimize and minimize how we use them. We must use them, and we can use them quickly, that's true, but we can still also be wise and use a bit less of them and optimize the use of them. Yeah, and also save money. Great point.
Okay, thank you for that.